So homework, if you turn it in today, you'll get full credit. Tomorrow, 10% off. Thursday, 25% off. Friday, 50% off. And I won't accept that after Friday. And Darby's absent, right? So here's a question. How many grams of hydrogen gas can be produced with 65 grams of zinc and 65 grams of hydrochloric acid. Get the doors locked. Unlock it, please. Okay, yeah, it's unlocked. And then you locked it. Just turn it. Just turn the handle. There you go. So, what do we do first? Balance the equation. So we have zinc reacting with hydrochloric acid. What's the formula for hydrochloric acid? Hydro means what? It means binary. It means it's H with Cl. So this is single displacement. What is this going to make? What does this make whenever it reacts? What do you think, Alec? Carlos? What's the balance, or what is the equation? So zinc is a metal, so it's going to be our cation. And during single replacement, we only have two things coming together. This is the anion, so the zinc is going to merge with the chlorine. This becomes zinc chloride. Zinc has a +2 charge. And we have hydrogen left over. So we need, and hydrogen is diatomic, there will be two of them. We have 2 hydrogen, 2 chlorine, so we need 2 of these. So our ratio is 1 zinc to 2 acid. What's the next step? Yeah, get the moles. So let's do zinc first. We have 65 grams of zinc. And the molar mass of zinc is 65.409 grams of zinc per 1 mole of zinc. So grams of zinc cancel out, leaving us just moles of zinc. So we get 0.99375 moles of zinc. And we have 65 grams hydrochloric acid. Chlorine is 35 roughly, hydrogen is 1 roughly.
Mariette Herrera, C.J. Anderson, Nicole Wells, Drake Fazio, Cassidy Sal, and Darby Don need to report to the front office, please.
So we add together the molar masses, and we get 36.46094 grams of hydrochloric acid per 1 mole of hydrochloric acid. Hello? He's not. I guess he's taking pictures. All right. Bye.
Lucas Lakey, come by the office to leave. Lucas Lakey.
And we get 1.78273 moles of HCl. So which is in excess? So remember that zinc can react with twice as much acid, and acid can react with half as much zinc. So that means this can react with twice as much, times 2, twice as much acid. So if I multiply it, it can react, with 1.9875 moles of HCl. So we don't have that much. So this means this is an excess. While HCl can react with a half, because the ratio is 2 to 1, and going backwards. So if I divide that number by half, it can react with 0.891365 moles of zinc. So this means zinc is in excess. So what's actually reacting, so what will actually react is 1.78273 moles of HCl with 0.891365 moles of zinc. This means 0.10238 moles of zinc will not be used. So, how much hydrogen will we get? So we determined that we're going to have 1.78273 mole of HCl, and we determined 0.891365 mole of zinc is a 1-to-2 ratio, and then we have a 1-to-1 and 1-to-1 right here. That means 0.891365 mole of zinc chloride and 0.891365 mole of hydrogen gas. So if anywhere you see a 1, it's going to be 0.891356, and then a 2, this 2 means we multiply that by 2 to get that number of moles. So we will make 0.891365 moles of H2 gas. And the question asks how many grams. So we know the molar mass of hydrogen gas, H2, will just be 2 times 1.00794. So 2.01588 grams of H2 is 1 mole of H2. And that is not the correct conversion because it's moles to grams. That's the wrong way. You should put it mole on bottom and grams on top, such that moles cancel out, giving us grams. And we'll end up making 1.796885 grams of H2 gas. By the way, assuming the gas is at atmospheric pressure, what would its volume be? Atmospheric pressure is at STP. So STP is 1 atmosphere and 273.15 Kelvin. So pressure times volume is equal to nRT. Solving for volume, volume is equal to nRT divided by P. Or number of moles is 0.891365 moles. And I've already forgotten the gas constant. Gas constant is 0.082057 liter atmosphere per mole Kelvin. Then a temperature of 273.15. That's really cold. That's 0 degrees Celsius. I'll keep it there. And then the pressure is 1 atmosphere. So you would end up with 19.979 milliliters of H2 gas. See, if you had a method to collect it, you get about 20 milliliters. And if it's at room temperature, which is 293, then it would go up to like 21.44 at room temperature. Oh, by the way, yesterday I did sodium. Or I told y'all can just put the table salt and sodium into water and then boil it to get rid of the sodium. That wouldn't work. I made a mistake. Because sodium hydroxide, actually, when you boil it, it turns into a crystal. So you'd end up with acidic salt.
Need a sophomore superlative. I need Olivia Reyna, Colby Sanders, Stephanie Parade, Jack Kilmer, Bailey Scott, Jeffrey Lacey, Taylor Bennett, Mason Manfield, and Tyler Bennett. Report to the office, please.
Let's see.
Excuse me, teachers and students, for a quick interruption. Juniors, it is in your email, it is open for you to vote for class officers. You need to vote today, and the voting ends today. Whatever the results are today, that will be it. That's junior, the 11th grade class officers. Thank you.
Let's try working this one out. Assuming you have 500 milliliters of 18 molar sulfuric acid. How can you make 25%? How can you make 100 milliliters of 25% sulfuric acid? And the percentage is volume per volume. And the density of this is 1 gram per milliliter, or 1.8 grams per milliliter. Let's see if this is actually a good one to work with. I already tell you 18 molar is almost 98% sulfuric acid. I'm trying to think how to turn 18 molar into a percentage. So 500 milliliters of sulfuric acid. So we know 1,000 milliliters is 1 liter. And the molarity tells us we have 18 moles per 1 liter. So we have 9 moles of acid. There are 9 moles in 500 milliliters. We can get grams. What is the formula for sulfuric acid? So there's no hydro. No hydro means it's an oxy acid. Oxy acid. So what does the it tell you? It tells you it's the 8 version of it. So sulfate. So it would be sulfate with hydrogen. Hydrogen is H plus. Sulfate or sulfur, SO4, negative, or 2 negative. That means we need 2 hydrogen. So its formula would be H2SO4. So the molar mass of that be 2 times 1.00794. 1 sulfur. Sulfur is 32.065. And 4 oxygen, which is 15.9994. So it has a molar mass of 98.07848 grams per mole. So we can take our 9 mole and convert it into grams. So we have 882.7 grams of sulfuric acid dissolved in 500 milliliter solution. So to figure out the percentage of the original solution, we know the density of it is 1.8. So we can actually figure out how much this weighs. That's that'll get me percentage.
This time we're going to do our freshman officer and the person. So I need Whitney Siegel, James Hall, Valerie Run, Jacob Wooden, Aaron Emerson, Emery After, Kit Thompson, John Patton, Seth Wells, and Lynn Carter.
Let's actually. And this comes out right, but then it's mass per mass. Never mind, let's skip this. Because that's... I'm mixing mass per mass, or weight per weight concentration with volume per volume. I can get mass per mass concentration. So 500 milliliters at 18 molar has a density of 1.8. So that means that we take 500 milliliters and multiply it by 1.8 grams per milliliter. That gives me 900 grams of 18 molar spheric acid. And to get the percentage as mass divided by mass, or weight divided by weight, we simply take our mass here and divide it by our mass here, and we get 98.0785% uric acid. But this is by weight per weight. And a nice trick is if you have the concentration times volume of one thing, that's a constant. So 98.0785% at 500 milliliters will give you a concentration of C2 times 100 milliliters. Solving for C2, the concentration and I should be doing 25% and a volume of 100. Volume D2. Oh well, skip this. I need to work this out later. I think that's it for today. How close are we all on finishing homework? How about you? Alright. So I was planning on just not accepting it after today. But I'm going to do this because I won't have time to grade it today after school anyway. So if you turn it in tomorrow, it's 10% off. Turn it in Thursday, 25%. Friday is 50%. What is this trick? I'm trying to work this out. It's the fact that I'm mixing up volume for volume and mass per mass. I want my final concentration to be 25% at 100 milliliter solution. I know my original concentration was roughly 98%. And to figure out how much volume you use, this would be the equation. So that means if you use B1 would be 25.48 or 49 milliliters. That means if you use 25.49 milliliters of your original acid and dilute it to 100 milliliters, you'd wind up with 25% mass per mass solution. But the question I wanted was volume per volume, or I should say weight by weight. And that's throwing me for a loop. I can't think at the moment how you go to weight volume per volume. Without knowing the density of pure 100% sulfuric acid. I don't think it's solvable without knowing that. If you change this to weight per weight, that would be the solution. Mix 25.49, or take 25.49 millimeters of 18 molar sulfuric acid and dilute it until the final volume, dilute it with water until the final volume is 100 milliliters. Or I should say, really, because you don't mix water into acid, you would start with roughly 50 milliliters of water, or 60, we'll do 60. Slowly add 25.49 millimeters of acid. Then the remainder of it, then add water until it gets to 100 milliliters. And add slowly water. And that would give you a solution that was 25% sulfuric acid when measured by weight per weight. Weight acid, or grams acid, divided by weight solution.